So, on the bench today, and I hope you can hear that fan's just kicked in, that's indicative of the problem, is this thing, a PA12040 4-zone mixing amplifier. So, it's quite a nice amp, really. See, on the back of it there's essentially 5 inputs. There's a channels 1 to 3, can be set to either line or mic level with phantom power or without, should you desire. And just channel 4 and 5 are just line level RCA style inputs. But it has 4 zone outputs, so you can send any of these 5 inputs to which of these zones you like in any manner of mixes. So, well, within reason, like from whatever level I have my channel 1 coming in, I can only have whatever zones I send it to, it will come in at that level on them. But yeah, you can mix and match them. It's quite a versatile little amp, and then it has quite nicely inside. Have a look in here. So there's 4 toroidal output transformers stacked together. Power transformer, nice toroidal one. Power supplies down there, and there's a 4-channel amp. Being that this is also designed for like commercial use, there's a telephone paging input on it, which I had one of these for fixing once, and the issue was that when you initiate the telephone paging circuit, it wouldn't mute. So it's basically, to get this circuit to initiate, you have to close a switch. There's like some contacts at the back you have to make, so that closes the circuit to say you want to use the telephone paging input. Then as soon as you start applying audio, the circuit comes to life, and there's 4 pole dip switch at the back, and you select which of the zones you want to send that audio to. However, for versatility reasons, there's a tiny little jumper just here, and moving the position that determines whether this circuit mutes the input or just mixes what it's sending to the zones you have it set with. And it is a bit odd, really, because I suppose if you went into it, imagine like it was a petrol station or something, and let's say there's music playing in the shop. Let's say there's a speaker in the staff room at the back, so you've got your different, you're using your different zone. You're using your different zone levels. Like, and let's say someone's on the forecourt smoking or whatever, or got their bike helmet, and whatever the cashier wants to tell them, they can pick up the phone. It'll initiate the paging circuit, and it would then send the whatever's coming in out to the forecourt speaker. However, it's great if there's no music or anything playing in the forecourt. So let's say you have the forecourt is primarily on zone 4. If you have the telephone paging circuit set to go to zone 4, as soon as you pick up that phone and start speaking, so the switch on the phone will initiate, close the contacts at the back here. The audio will then spin the circuit into life, as it were, and it would send it out on zone 4. However, should you say have a shop or something and you want the audio, say there's like that background music playing, and you want the audio to mute when you pick it up, you'd need the mute connection enabled. But the problem with that is, it doesn't matter if you only have this circuit set to go to zone 4, zone 1, zone 2, any number of them, it will mute everything. It will mute all of these inputs. Channels 1 to 5 will completely be muted. It bypasses whatever you have on here, and it goes direct to the inputs on these zones. So, if you had the telephone paging system set so it was just going to send an announcement to the staff back room, so let's say they had music on in there as well, because they're working away, it's the warehouse, and you wanted to be able to, at the till, for instance, just say you wanted another member of staff coming out. If you picked up that phone to announce it, although you only had this, say, set to go to like zone 1, which was the staff room, or not the staff room, like the warehouse at the back or whatever, storeroom, that's the word. Although it would only send the audio to that zone with the mute circuit on, it would mute what was playing in that zone and send the audio from this circuit to it. It would mute all the other zones. As far as I really think it needs a dedicated mute on it, because it mutes everything. And there is a priority input as well. Channel 1 has a priority switch on the back with a set of contacts again for a switch. And if you press that, again, it will mute all 4 of these inputs and then send audio to whatever zones you have channel 4, which again I feel is kind of a bit of a bad design, because I would only want it to mute the zones I actually have the input set to. You know, again, if I only want to send an announcement out to zone 2, so you know, you only have this set to go to zone 2. As soon as you press that priority switch, it will mute everything. You don't have to use the priority, just like the telephone paging one. You can have it so it just sends this in as a general mix to whatever zones you have it as. But then if you're trying to make an announcement, you generally don't want to try and make an announcement over the top of music, and it just makes it inaudible. So you have the mute functions enabled. So yeah, it's only got broad, like full channel muting on it really. It doesn't have dedicated muting depending on the settings you have that telephone paging board and this set to. So yeah, as a result of that, factory default on these seems to be to have muting turned off. So like I said, I got one sent back with the muting issue was that it wouldn't mute on the telephone circuit, well, telephone paging circuit. And yeah, and it's just that jumper needed moving is all. It is what it is. It's, you know, it's done it for cheapness, and it costs money to start making individual mutes on everything, so it just broad mutes. But anyway, yes, the problem on this amplifier, I've waffled on long enough now. The problem. So if you can hear just a last one of these I had on the bench as well, fans kicked in. I was going to say, if you could just hear before that kicked in like an odd whining noise. I couldn't figure out what it was on the last amp, why it kept making this weird whining noise before it. Well, it just kept making this weird whining noise, and then eventually realised it was the fan just on the cusp of kicking in. So it's an odd one. It sort of must, because it's only really on off. It's not a speed controlled fan. For some reason, just before the transistor that turns it on actually kicks in, it just leaks enough current for the fan to try and spin but not spin, and it makes a sort of whining noise. But yeah, anyway, if I put my meter down here and start probing the output to the transformers, so you know, half a millivolt, half a volt, just over a millivolt, yeah, 170 odd millivolts. If I turn this off and try and do a DC resistance without that noise pissing the camera off too much, if I do a DC resistance check on these power well, not power, 1.2 ohms, and bearing in mind 0.7 of that is what my meter switch is dying slowly. So 1.2 minus 0.7 is 0.5, isn't it, I believe? See what I get now. So that should then come up at about an ohm. So yeah, half an ohm. So basically 170 odd millivolts through half an ohm is 300 odd milliamps of current, which is no good at all. You do not want 300 milliamps of DC offset in a toroidal coil. You don't want any DC current going through a toroidal coil. They saturate terribly. So it's drawing a huge amount of current through one of these transformers on this amplifier just here, because this is the bit that's getting hot. This side's stone cold, it's cool at the back, hot this end. And when you probe it, it's this one. So yeah, there is an amplifier with this amplifier. There is an issue with the amplifier on this board down here. So I need to strip it out and see where this DC offset is coming from. So let's delve in and see what we find. Again, and yeah, before I do, this is where intermittent faults or odd faults are a pain in the ass, because again, if I just hooked this thing up and gone through all the settings and cranked it up and stuff, I'd say, yeah, it's working all right. You know, you generally find a quick 5-minute check, you go, that's fine, I'll send it out. It's leaving it running on the bench and suddenly hearing the fan start kicking in and stuff whilst I'm testing it. I thought, right, let's pop the cover off and have a look inside. And then, yeah, it became blatantly obvious after probing around there's an issue with this. So I don't think it would firmly run away sat idle, but with all the other channels being driven, because again you use these in large environments, so they're always generally being used quite hard. You know, if you've got multiple speakers, it could be being driven quite hard all the time, even though the output of each speaker is quite low. And with all of them combined together, they might be generating enough heat for this to actually start tripping into protect mode. So it's not good anyway. Even if it didn't cause it to go into protect mode, it's not good having that fault. It's detrimental to the way the amp works. I'm going to say at a guess, when you start trying to crank it up, you probably find it distorts terribly on whichever channel that is, because the DC offset, that core is going to be so close to saturation already in that direction. When you actually start trying to apply an AC waveform, it's going to just run out of the core, is going to saturate, and it just won't amplify properly. So yeah, let's pull it apart, see what we can find. So this board is incredibly difficult to try and do any reverse engineering on, because it's dual layer with all the transistors at the top, and yeah, it's so many tiny little tracks and wires that just go through absolutely everywhere. It is difficult, but I have managed to ascertain the feedback loop is indeed working, and it's, from looking at, you know, I've not been able to exactly sketch it out, but from what I can gather, I think it is a mirror image topology. So there's two feedback transistors, two input stage transistors, so basically two long-tailed pairs feeding into two voltage amplifier stages. Yeah, and I think there's like some constant current sinks or voltage references or something. It's a bit, like I said, it's a bit difficult to say for certain. But what I have done is, after probing around, like when it goes onto its DC offset, it's high enough so that basically one of the feedback transistors isn't even turned on. The forward bias on the base emitter junction is too low to turn the thing on. The other one's basically doing its very best to rob all that input stage current and try and compensate by turning the voltage amplifier stage on. And the beauty of having four of them is it's quite handy for checking voltages and temperature and stuff. And on the other three boards, all of these transistors run absolutely ice cold with no load on them. But on this board, these two here are getting quite hot. So that suggests to me that maybe one of them is leaking current, and the other one, due to the feedback network, is trying to turn on more to correct the deviation offset current, which is causing the two of them to feed into each other. It depends how they're linked. Or it could be like a leaky driver or something. It's the voltages on the drivers base to emitter and the output transistors seem about right. Well, one of the drivers is actually low, but if there's DC offset and that transistor isn't even turning on, that would explain that. So I think what I'm going to be reduced to is the old pull and swap. So just one transistor at a time. So start with the ones that are getting hot. So just do one of them, apply power, see what happens. Then the next one, apply power, see what happens. Can't see any open resistors, dodgy solder joints or anything. Probing around everything at the bottom side I've managed to test, and it's not the easiest of things to do with the circuit the way it is. Seems to be connected and in circuit, so I'm going with a dodgy transistor. I'm fairly certain it's one of these ones here, one of these two, I think. So yeah, it's basically start doing some swapping and see what happens. It's not the preferred method of fault finding, but again, when you don't have a service diagram and you're just trying to go on what you can probe, it makes life a little difficult. With a service diagram, this will be a piece of piss. I could see it's such a simple circuit, really. It's just the way it's laid out makes it difficult. Yeah, with a service schematic, I could work out straight away what connects to where and what I should be able to measure, and it would be pretty easy to, just through looking at some voltage values, to determine with a pretty high degree of confidence where the faulty component would lie. So yes, I've done all I can probing wise. I've narrowed it down best I can. So yeah, now it's, like I said, it's a case of do some swapping and see what happens. And when you do swapping, you don't go swapping all of them at once, because, you know, where was your problem? It's annoying. You pull one out, pull the other out, swap them over. Well, you don't technically have to swap them over. I guess you could just put them in this side, but seeing as this amp's going to be powered up, it's good to swap them over. And likewise, if the fault then switches the amps, you know it was definitely the part you've just swapped. So yep, swappity swap and see what happens. Well, it's a few days later since I filmed that first part of this video. That was like, might have been early on Christmas Eve. It's now Saturday. What, Christmas Day was Wednesday, wasn't it? So yeah, that was Tuesday then. So when I started filming this. So anyway, yeah. Yeah, wherever I left off, I can't even recall. So I finally sat down today, earlier on, and I recall saying in the previous part of this video that I was at the point where I was going to start swapping transistors. So I went and marked all the transistors on one of these sides with a pen and basically swapped them one by one and no change. So I then, as painful as it was, managed to at least reverse engineer the basic topology going on. Now I was adamant, I was absolutely certain that I had probed every single component on here, which, you know, you don't always get the correct value showing on a meter when you start trying to probe stuff in circuit, because other stuff is connected to it in series and in parallel, and it skews the readings. But I was absolutely certain I'd at least probed every single one of these diodes. Well, I've, like I said, changed the transistors, no change. I've gone around and probed all the resistors. To be honest, it was actually pretty good. Only the odd one or two was showing some odd readings, but if you went to the other board and found like the same resistor, it would read pretty much the same. And it was only when just giving these diodes one last probe, which one was it? This one. Let me just make sure I've got the right. Yeah, D19. That one just there was showing no continuity, and the second I went to unsolder it, it just snapped in half. It was a broken diode. I've replaced that and job done, fine. I was certain, I was bloody certain I'd probed all them diodes, but I must have missed that one. I just absolutely must have missed it. Well, the other option is, say it hasn't broken where the actual semiconductor die is, but it's further along. If I'd probed it, it might have just been making the connection in the middle as I was putting the pressure on to probe it, and it was giving me a reading, but I don't know. All I know is it's now fixed. It was a lot of messing around. As you can see, if I zoom back in, I've had to put some solder bridges on, because where some of these transistors were, let's see if I can find some on the other board. So well, that shows up, but you can see like the legs are bent over, so you have to be quite forceful with the desoldering gun to actually push it onto the leg and bend it up and get the heat in and desolder it. And so that's, you know, damaged a few pads and stuff, so I've just put the solder bridges in just to make sure. So the only thing left to do now is put it back together and see if it's now working. Well, here she is, back together, and clipping, just out of clipping, working fine. So just try that at lower frequency, see how the transformer core is behaving. It's a, what do we have, like 100 hertz? Let's see, 100 hertz. It's oh, it's one wobbly, no good. Don't want wobbly. Oh, the joy of live cinema. Yeah, just get to it already. Ooh, let's knock that back a bit. Yes. Seems to actually it's actually my scope clipping. Let me just yeah, I'll put it on times 10 mode. What does that reckon? Let's get the old multimeter out. The old multimeter's pretty accurate at low frequencies, and it says, yep, 25 volts. Both, it's about 25 volts is what it will clip into a 4 ohm load. Got some more resistors for dummy load, they're not on it yet, but that should take it up to 400 watts with adequate cooling. What was it, 25 times 25 over 4, that's 156 watts it's putting out. Not bad from a single pair of output transistors. So yeah, that was it. Just that one stinking little diode, which if I could have found when I first took the thing apart, would have took me seconds. It's not been too bad. I don't know, probably had it for about 4 hours a day, messing about, probing around, and dinner break and everything. So yeah, not too bad. It's working. That's what counts. So yeah, DC offset is just a few millivolts now on every channel, as it should be. Heatsink's warmed up a bit because I've just been thrashing it. And yeah, job's a good one. So yeah, as always, thanks for watching and catch you next time.